Okay. So I think this is, I don't know if this is the moment you've been waiting for, but it's the moment that I've been waiting for. We're going to start to do some real statistics now. Up to now, it's just been baby stuff. Okay? All right. So we're going to start with something that you've probably heard a lot of times, 9.1, which is confidence intervals for population proportion. Okay? Now, I don't think chapter 9 is too hard. It's really, when we start getting into hypothesis testing, that's when you guys are going to be like, oh, this class just got hard. Okay? So, but this is a good foundation for what we're doing. All right, actually, well, I'm just going to give you the formula. This is the way they have it written in the book. It's not my favorite format, but it works. Okay? So what does P represent again? Population proportion, right? So the idea with the confidence interval is, as you know, when we did the, really, I think probably, when we talked about the central limit theorem, okay? You remember when we did that demonstration where I showed the IQ scores and how there was, and then we took each row and we figured out X bar for each row, and there's going to be some natural variation going on, right? Okay. So if I do a political poll or any kind of a poll, if I do it this week and if I do it next week, there's going to be a little bit of variation, probably just because I talk to different people. Okay. So the question is, you always know there's going to be some sort of a variation. And so the idea here is you want to figure out that that your poll may not be exactly correct, but it's going to be within hopefully just a few percentage points if you did your poll well. Okay? So the idea here is we're going to bracket the population proportion between p hat minus z sub alpha over 2 times the square root of p times q over n. And on the upper side, it's going to be exactly the same. P hat only it's going to be a plus z sub alpha over 2 times the square root of pq over n. Okay? So that's the formula that I'm going to give to you for figuring out confidence intervals. Now, this I know can get a little bit confusing here, but here's the kind of the basic idea. Okay? So you do some sort of a poll. Okay? Now, the idea here is your true population mean is going to be right there in the middle, because we believe that it will be normally distributed if what? It's okay to assume normally distributed if what?
If NPQ is greater than or equal to 10.
All right, NPQ is greater than or equal to 10. Okay? So long as my sample size is large enough, then I can assume a normal distribution. So the idea here is you're going to get some p hat here, or maybe it's going to be here, or hopefully it's going to be right there, but it's going to vary. Okay? So if this represents the sampling distribution, the idea here is, well, if I go out far enough, we know, for example, with the 68, 95, 99 rule, okay, if this is P, if I go out one standard deviation, I've got 68%, right? And if I go out 2 standard deviations, I'm 95% of my data. And if I go out 3 standard deviations, I'm 99.7%, right? Okay? So the idea here is this is your number of standard deviations, okay? The most common confidence interval, and it's so common that people usually don't report it, is 95% confidence. So you remember yesterday, I think it was yesterday, when I said, well, if you just take the standard deviation and you multiply it by 2, I was using the 68, 95, 99 rule, okay? So then if I go out 2 standard deviations, I can be 95% confident that the true proportion is between whatever that value is and whatever that value is. Does that make sense? Okay. And so the idea here is you refer to alpha as your significance level. Okay. So the idea here is I could choose to be 70% confident, or I could choose to be 80% confident. Right? I can choose whatever confidence level I want to be. Let's say, for example, that I'm 80%, that I want an 80% confidence interval. Okay? So if I want 80% confidence, how much is in the tails?
20.
Yeah, I got 10% on each side, right? Okay, so my significance level would actually be both of those combined. So in this case, if I wanted 80% confidence, my significance level would be 20%. Does that make sense? So the idea here is, as you can see here, I've got 10% in each of the tails. So what I do is I take my significance level, I divide it in half. Okay. So if I'm using the chart, let's say I wanted to find something. Oh, that's interesting. Move. Okay, so if I'm using the chart, let's say that I wanted to be 80% confident. I need to share this. Share. Okay. Okay, Z distribution here. Okay, so if I want to be 80% confident, how many standard deviations do I need to be away so that I can be 80% confident? How would you figure that out with the chart? So I want to find 0.10, right? So if I time 10% here, was 11, 9, okay, so we're getting really close here. Oh, look at that. That's about almost exactly 10% right there. You see that? What number, what's my Z score that corresponds to that? Negative 1.28, right? So if I go out, in this case, if I'm assuming this is a standard normal distribution, I'm going to go out to negative 1.28 and positive 1.28, okay? So that becomes my Z sub alpha over 2. Does that make sense? Okay, so I'm going out 1.28 standard deviations on both sides. And what I would say in this case is we are 80% confident that the true proportion of whatever you're measuring, I'm just making this up, people who support Donald Trump or higher school taxes or whatever, okay, is between, and then you always do the low number and the high number, okay? Now, another way to think about this is, okay, remind me, what does this represent in my formula? That's my standard deviation. So I'm going to take my standard deviation and I'm going to multiply it by, a lot of times we would call this our critical value. This whole piece here, sorry, right to there, that becomes your margin of error. Okay? And you're going to add and subtract your margin of error. So sometimes, a lot of times in the news, what they'll do is they'll say, hey, we got a value of, 58%, and the margin of error is 3.5%. A lot of times that's how they'll report it. Okay. Typically in this class, you can do that, and I want you to be able to find that, but I'd rather you just said it's between, 20% and 30% or something. But you always put the low number first and then the high number first. Does that make sense? Okay. So this is kind of a generic problem. Let's do a real problem here. Go ahead and open up Excel. Just open up a new page. All right, so Pew Research conducted a poll of 935 teenagers, 12 to 17, and asked if they participate in social media. 598 reported they did. Obtain a point estimate. Okay? Now that's kind of a generic term to say, what percent did they get? Okay? And actually, let me back up a little bit here. Let me stop sharing for just a moment so people can see my board a little bit better. For those of you who are watching at home, why aren't you in class? I know. I actually saw somebody walk out to me. Oh, whatever. Okay. He's losing out. Okay. At any rate, here's kind of your, instead of writing it this way, here's how I would prefer to mention it. You're going to have some sort of a point estimate plus or minus some sort of a margin of error. Okay. Your margin of error is going to be based on your standard deviation times your critical value. Okay. So some examples of point estimates. So a point estimate, you can think of that as a statistic. Now, what is a statistic again? Is it based on the population? No.
Sample, sorry.
Based on the sample. So what are some examples of point estimates that you've already learned? What are some statistics that are based on samples? P-hat would be a point estimate. Okay? What's another example of a point estimate? X-bar. X-bar. What's another example of a point estimate? Mu is not a point estimate, it's a parameter. It's based on the population. Okay? The whole idea, so here I'll give you the third one. The third one that we're probably going to use is S. Now, typically this is a really good general formula for a confidence interval. It's going to be a point estimate such as p-hat or x-bar plus or minus some sort of a margin of error. You get to decide what you want your margin of error to be. It's based on how confident you want to be. You want to be 90% confident? You want to be 95% confident? You want to be 99% confident? You get to choose that, although in the problems I will choose it for you. But in real life, you can be as confident as you want to be. The most common confidence level is 95%. Okay, so you can think of that as about 2 standard deviations. Okay, if I forget to ask you, like I say, I want you to create a confidence interval, and I don't tell you what I want the significance level to be, assume that 95% is what I want. Okay, that's the most common. Other common ones are 90%, 99%. Yeah, those are the most common ones. Now, having said that, I will just give you a pre-warning. This one is not going to be symmetric. Okay, so this is your typical, but it's not always. Okay, in the case of standard deviation, I'll teach you a new distribution. It's going to be the chi-square distribution. Just pre-warning you, that one's not symmetric, and so you can't add or subtract. One of the beautiful things about the Z distribution, it's symmetric. We also have, I'm going to be teaching you probably next week, the T distribution is also symmetric. The chi-square distribution is not. And you're not going to like that it's not symmetric because it's a little bit harder to use. Okay? It's not hard, but it's a little harder. We love symmetry. Okay? It makes our lives a lot easier. Okay? All right, so let's go back to this. Okay. All right, so we've got our poll here. obtain a point estimate. Okay, what do you think the point estimate should be called in this case? What are we dealing with?
The median.
The median? Mm-mm. What'd you say? We're dealing with a sample size, but that's not what I'm referring to when I'm talking about a point estimate. It's going to be, is it going to be p hat or is it going to be x bar? It's going to be p hat because I'm dealing not with a probability, I'm dealing with a proportion. I am dealing with probability, but that's different. In fact, going back to my picture here, another way to think about this here, if I go back to this picture here, okay. If I want to be 68% confident, that means 68% of the time I'm going to be right. 32% of the time I'm going to be wrong. Okay. If I go out 2 standard deviations, the probability I'm right is 95%. The probability that I'm wrong, 5%. Okay. In fact, I hope we have enough time. I'm going to show you really cool. I will post that video because it'll take too long. Posted a video on the last election. I stayed up way too late lamenting the results, but also there's some really good real life, real world statistics. I did it for my online class. I think you guys will enjoy it. So at any rate, if we have some time, I'm going to try to go over that today. All right, so my point estimate is going to be called p hat. So how would I figure out p hat in this equation? Or in this scenario?
598 divided by 935.
598, that's just x over n, right? Divided by 935. Okay, piece of cake. Okay, now let me ask you that I want to find a, well, let's just go with the common one, 95% confidence interval. Okay, now, so my formula is basically, as I mentioned earlier, p hat plus or minus p hat plus or minus my margin of error. Okay, so I'm going to have a lower and I'm going to have an upper. Okay, here's the formula that I'm using. Okay, so my p hat is going to be, in this case, about 64%. Plus or minus, I'll do the minus first, times z sub alpha over 2. Okay, now 2 ways I can find this. If I'm using here, I will show you here at the bottom, they have common confidence intervals. Look at that. Okay, down there at the bottom, is that too low for some of you? Okay, so these are the most common ones. So rather than go fishing for it, now remember, I told you, according to 68, 95, 99 rule, you're 95% confident of 2 standard deviations. If you want to be more accurate, it's actually 1.96. Okay? So that's more accurate than the 2, but that's basically where we're getting 2 from. Does that make sense? Okay? All right, so my critical value, my z sub alpha over 2 in my formula here is going to be 1.96. Okay? So maybe I'll put that on here. So my critical value is 1.96. Okay. So as I'm using this, I'm going to do my p hat, which is right there. I'm going to subtract my critical value, and I'm going to multiply that times the square root of, and now it says p. Do I know what p is?
P,
Isn't that p hat? I don't know what p is, right? But p hat is what, remember I said, I think it was yesterday, that it was an unbiased estimator of p? It's close enough. Okay? Normally I say you should pay attention to the p versus the p hat. This one you can sort of ignore it a little bit. If you don't know p, a p hat is okay to assume here. So my p hat is going to be this, or my p, and then I'm going to multiply that times 1 minus my p, and I'm going to divide that by my n, which I didn't write down, was 935. Okay, so there's your formula. So on the lower end, I got 0.6088. Now, if I copy this and paste it, notice it didn't work very well. However, if I copy it up here in the formula bar, Control C to copy, Control V to paste, I should get the exact same number, and I did. And all I need to do is I need to change that minus to a plus. Now I've got the upper bound. Okay? So my conclusion here is we are 95% confident that the proportion of teenagers in social media is between 0.6088 and 0.670. I'll round that to 4. Okay? Yes. Which one? This one? Okay. Let's see if I can make this a little bigger. So your formula is going to be your p hat, which I found up here. And then you're going to need to do plus or minus. I did the minus first because I'm on the lower side. Times your critical value, which I looked up on the chart. Times the square root of p. I don't know p, so I'm going to substitute p hat in this case, which is this number here, times 1 minus that number divided by 935. Okay? Does that make sense? You're going to use this formula over and over. Now, the last thing I want to talk about is sample size calculations. In fact, well, I'll just do it here. Don't need those numbers anyway. Okay. Oh, actually, maybe I'll just write this on the board. Stop sharing. Okay. So these are your sample size formulas. Okay, there's 2 of them. Okay. If you have a prior estimate, okay, then you're going to do p hat q hat times z sub alpha over 2 over e, where e represents your margin of error squared. That's going to equal your n. And if no prior estimate, then it's going to be n equals 0.25 times z sub alpha over 2 over e on z squared. Okay? So, E, which is your margin of error. Okay, so let me just do a quick example. You think 10% of people drive to work.
Good question. So on the margin of error, do we, doesn't matter if we do it positive or negative?
On the margin of error, it's always going to be positive. Well, it doesn't matter because you're squaring it.
Oh.
So, carpool to work. A new law is passed encouraging carpooling, and you want to see if it has increased. Assume margin of error is 4%. Okay. What sample size is needed? Okay. So based on this scenario, am I going to use the first formula or am I going to use the second formula? Oh, I'm not sharing. What do you think?
First
First one says a prior estimate. What's my prior estimate? 10%. Okay, so in this case, I'm going to get n equals, I'll do this real quick. So my p hat is going to be what? 0.10 times 0.9 times, now, oh, I didn't ask what the confidence level. I guess I need that before I can do this. What confidence level do you want? Let's say 90%. This would be a little different. 90% confidence. Okay? So n equals, okay, so I've got my 0.10 times my 0.9. Now I need to figure out my z sub alpha over 2. Okay, the common ones are there. What's my z sub alpha over 2? 1.645. If it's not one of those numbers, you got to go fishing for it in the chart. Okay? So 1.645, I need that in parentheses, divided by 0.04, that's my margin of error, right? Squared. Okay? Now, let me ask you, what does that round to? Because you're going to be talking to people, right? You need a whole person? No, it rounds to 153. Okay? So always round up. If it's 152.01, that's 153. The reason why is because if you stop at 152, you're going to be less than 90% confident. You're only going to be 89% confident. Okay? Now, really quickly, what if no prior estimate? What if you had no idea how many people carpool? You're going to use the second formula, which is 0.25 times 1.645 divided by 0.04 squared. Now look at the difference here in population, or in your sample size. 422, it's a whole lot bigger. Okay, actually that rounds to 423, right?
In both cases, that would round up.
Oh, in both cases round up. So this is 423, this is 153. Okay? All right, so we love prior estimates if we can get them. Okay? See y'all tomorrow. No, you won't. See you on Monday.